All right, anatomy and physiology students. This video is going to take us through the histology slides for the gut and digestive organs. On the course website, what you want to be sure you're following along as you do this is where the wish list is for these structures. Under your gut and digestion, remember we just have for lab the food testing lab. The anatomy and histology wish list is under liver and metabolism, and there it is, gut and organ, abdominal organ anatomy and gut and abdominal organ histology. If you open that up, you'll see this nice wish list, and I would strongly recommend either printing this out or having it in front of you as you study all of these histological structures, because these are the things I actually would expect you to know. For the esophagus, the three layers, mucosa, mucosa muscularis, externus, that you'll see for every part of the gut or of the actual digestive organs, and then some details of each of those layers. A lot of those, as you'll come to see, are repeated. For the esophagus, the stomach, intestines, you'll see, I don't differentiate into duodenum, jejunum, and ileum, but just the small intestine in general, and then the large intestines, and then a few structures for the liver and the pancreas. I believe that the best place to see these structures is going to be on the PAL program that you should have access to if you bought access to the publisher's website. If you don't yet have access to PAL, just to show you, right here on the course website, on the main page, you will find in the box at the top a little link providing access to PAL. Actually, you'll find that access on my A&P1 website, because I assume all my students have it from there. Online access to purchase PAL right there. You can purchase it independently. I believe it's about $40. Back to PAL program. We're looking under histology, and we're going to be looking at the digestive system down here. And I'm just going to go turn the labels on and go through and take you to some of the key features that you would want to pay attention to. Remember, when you're using PAL, you can see what you're observing. What slide you're observing is labeled up here with its magnification. You can see where it's come from right here, and of course you can turn on and off the labels if you want to test yourself. You can use their quiz, but I warn you, sometimes they test you on things I don't. So if you're going to use their quiz, check and see if it matches our course wish list. Okay, just to remind you, there it is. Our course wish list is the main thing you want to focus on. All right, going through this real quick. This is the esophagus. You can see the layers are going to be the submucosa. The layer, the mucosa is going to be the layer of epithelial tissue, and then you're going to have the submucosa, which is going to be that layer of subcutaneous fat and other material, and then you're going to have the layers of muscle around there. You're going to have that for all of the gut organs. Mucosa, the epithelial tissue, and and what holds it up, the submucosa supporting connective tissue layer and blood vessels, and then a muscular layer around there. That's at low magnification. If you look in a little closer, you can see that nice stratified squamous epithelial layer in the esophagus, almost looking like skin that's going down the middle of your esophagus. The submucosal layer with its typical kind of fat looking and lots of blood vessels in there, and the muscular layer of smooth muscle. Very typical of all the gut organs. This is an even closer look at the stratified squamous epithelium of the mucosa, or the internal layer. And this is looking all the way across the esophagus. I think it's interesting to notice that it's all collapsed down. The lumen, or the part down the middle, is all collapsed down unless you're actually swallowing something when it expands out to open that up. And then, of course, the mucosal layer, the submucosa, and the outer muscle layer. All right. We could keep on going on the same thing with the esophagus. There's not that much else to see there. On the stomach, the mucosal layer of the stomach is extremely unique, and it has all of these pits, gastric pits, diving deep in there, and we'll get a closer look at those. And then we usually have a couple of layers of muscle around the outside with a typical submucosa with blood vessels and connective tissue supporting the inner mucosal or epithelial tissue lining the organ. Remember, everything is always lined on the internal surface with an epithelial layer. There's a better look at those gastric pits. Okay, these are where the digestive enzymes of the stomach are produced. They're pits that dive deep. They're not really showing this. They dive deep into the mucosal layer. They're lined by parietal cells and chief cells that produce hydrochloric acid and pepsin, or the precursors of those two things, which is what break down protein in the stomach. Then you have that submucosal layer right here, and of course the outer muscular layer. So that's a pretty nice look at this. I think we'll get a nicer, even closer look at those gastric pits going in, the parietal cells underneath them, and again, that's a pretty good view of the stomach. This is more of the same of the stomach. There we go. You can really nicely here see the difference between the chief cells, looking like those very flat, washed out cells, and the parietal cells in the mucosal pits, and maybe we have even nope, now we're on to the intestines. So on the intestines, we've saw these in A and P1 as the great example of a columnar epithelium on the surface of the small intestines with those goblet cells up there and the simple columnar cells in the epithelial lining. Remember, the intestines are also going to be, having those folds on them. They're going to have villi sticking out, and that's where you're going to see the columni, the simple columnar epithelium on the surface of the villi. Okay, continuing on with the small intestines, again, I'm not asking you to distinguish duodenum from jejunum and ileum, so we'll just look at this as in general. Not that much more to see on this slide. There you can see those villi sticking out. And then, of course, you have the submucosal layer and a pretty thick muscular layer. As we continue on, nice look at the close-ups of a villi, the nice columnar epithelium on the surface there. You can even, I guess, sort of see some microvilli on the very surface of those cells, some nice goblet cells in there. The muscular layer with two layers of muscle, circular muscle and a longitudinal layer, very separated and distinct. Again, more look at the duodenum with its layers, not much new to see there. And as we move through the jejunum, like I say, since I'm not asking you to distinguish these, I'm going to kind of go through here pretty quickly because it's a lot of slides to look at. There is, I believe, something else you could pay attention to as we move along here, which is if this is the inner layer of the small intestines with those villi and the columnar cells on the outside. These are Peyer's patches that we see just under the surface of the epithelial layer, and these are very rich in immune cells. When you look at them, it doesn't just look like a typical submucosa. I'm just going to hide the labels for a minute. Well, they're still giving that to me. It doesn't look like a typical submucosa with all of the just connective tissue and blood vessels. You have these very rich cell-bearing layers that are full of immune cells, obviously ready to go after any potential foreign invader that would come across the surface of the gut that would be present in the food that we eat. As we continue along, there you can see a close-up of the Peyer's patches. These are basically a reticular connective tissue, lots and lots of lymphocytes and other immune cells on connective tissue in there. And maybe they're giving us an even closer look. All the tiny little dots in here are mostly lymphocytes and other immune cells. And if you look closely, you can see interspersed throughout there some collagen fibers. Okay, moving along. Now we're on to the large intestines. In the large intestines, again, typical submucosa, mucosal layer, some circular layers of muscle. You have these Taenia coli, which are strands of connective tissue that kind of throw the large intestine into those typical house tree or kind of pouches along the length of it. And as we continue along, that slide was actually showing us the serosa. That would be the outer visceral peritoneum that's on the surface of the small intestine. So the food would be in here, or the rest of the breakdown products that are left over, and this is where you would have on the outer surface of the large intestines. It's parietal or visceral peritoneum. Okay, here you can see again what I think really distinguishes the large intestines is a thick muscular layer. You have a lot of mucus-producing goblet cells. You don't get the gastric pits, and you don't get the villi and the columnar cells of the small intestine, so a very different look to the epithelial layer on the inner surface. Again, those intestinal crypts, as they're called, kind of coming in like this. Lots of water absorption here happening and not much else being absorbed across that surface. Okay, now we are on to salivary glands, which we look at in A&P1. I don't have you learn anything on the salivary glands, so I'm going to skip right through them. But I would like to show you the last couple of things here. The pancreas, where when I look at pancreatic tissue, I'm looking at lots and lots of glandular tissue. Ducts going everywhere, lots of cells, and the main thing, so there's the ducts, and then these islet regions that look like they just have a different kind of cell in them, and when we look at them close up, again, those pancreatic islets, they're, remember, endocrine cells that produce insulin and glucagon. So they have ducts going down the middle, but no real blood vessel. They don't ever come together, and they just secrete right out into the blood. I mean, you can't really see that here, but there you can see how different the pancreatic islets look like. And around it is this more generalized glandular tissue. So that's a typical look of what the pancreas looks like. Again, you have ducts going throughout the pancreas. You have the acinar tissue that's going to be producing the digestive enzymes that get secreted into the gut through the pancreatic duct itself as an exocrine organ, making mostly amylase to help digest our food, and the pancreatic islets producing insulin and glucagon, those regulatory hormones in the blood. Then we can go to, again, there's just a more close-up of all those things again, an islet, a duct, the acinar tissue, and more of the same on the pancreas. The last thing I would like to show you, I love this tissue, the liver, because it is so distinctive. When you look at these liver lobules, you can see they have kind of a five-sided look to them. That's very distinctive. If you look at it even in higher magnification, what you see is there's a single liver lobule. They almost look like pentagons like that. They have a canal in the middle that's called the central vein. That's where the blood drains from the liver. Remember, the liver is mostly a blood processing organ. And in the corner you have the triads. Why a triad? You have a regular artery bringing oxygenated blood. You have a portal vein bringing blood rich in nutrients from the gut. And then you have a bile duct that's going to take bile, the sort of result of all the processing, away from here, and the rest of the blood will continue down the central vein. And then you have all these little canaliculi, or tiny canals, going from the triad into the central vein in the middle. So as we continue here, there's another closer up look at the triad. I wouldn't necessarily expect you to be able to tell these components of the triad apart, but mainly when you're looking at, there's just a beautiful view of that five-sided typical look of the liver lobule. Recognize that, recognize the central vein, and then they're not showing labeling it, but the triads in the corner here. So again, I wouldn't expect you to be able to distinguish these different parts of the triad. So I think that's about it on the liver. I hope that that's a helpful quick review of these structures. I want to remind you one last time while you're doing this, be sure that you're looking at the gut histology wish list. And there's one other resource that you might like to be aware of on the course website when we're looking at, again, under liver and metabolism. There's a gut histology image guide. These are different images than the ones that are in the PAL up there, and it's not wanting to open for me right now, but they're actually hand-drawn images. They bring out certain features much more clearly than in the PAL. You could use them to make your own drawings to guide you, but they're truly beautiful images there, so I would recommend you to take a look at that as well. So study hard. Let me know if you have any questions on the gut histology, and we'll see you in lab.